The diagram shows a block A of mass 3 kilograms lying on a smooth horizontal table. It's connected to an object B of mass 5 kilograms by a light inextensible string which passes over a smooth light pulley P fixed at the edge of the table so that B hangs freely. Initially, the system is held at rest with the string taut. A horizontal force of magnitude 75 newtons is then applied to A in the direction PA so that B is raised. Find the magnitude of acceleration and the tension in the string. So quite simply, getting used to this question here now, you just need to appreciate that on this table, that we've got this object A resting on the table. Okay, and of course object A has got a weight, which of course because it's mass 3 kilograms, the weight will be 3g, and it's resting on the table, so the table is reacting, isn't it? Okay, a reactionary force, which will be equal of course to the weight because it's balanced there perfectly. Now there's a pulley here, smooth pulley, remember, so then if there's a smooth pulley, the tension is the same throughout the string. The string is inextensible, so it doesn't stretch, which means then that the acceleration is the same throughout, the velocity is the same throughout. Now you've got B, so there's B there and there's A here, and object B is a heavier mass, so the weight will be 5g. Now you'd think now with this hanging off the table that if it was to be released that it would go this way, yeah? You'd think B would fall, and quite rightly that's what would happen. However, it says a horizontal force of magnitude 75 is then applied to A in the direction PA. So if you think about the direction PA, P to A is going that way, isn't it? Okay, P to A. So there's a force applied to object A in that direction, PA. So something is pulling it that way, like a string maybe attached to it, or somebody's pulling it, and the magnitude is 75 newtons. And what happens then is that it actually pulls B up. Okay, so the acceleration then is that way, and of course then A goes along this route along the table, so V moves up across the pulley. The acceleration is the same throughout as we discussed because the string is inextensible, it just doesn't stretch. So now we can apply Newton's second law to work out A and the tension in the string. Now the tension in the string, of course, the T here is pulling up object B, but the T will also be acting this way. You need to appreciate that there, yeah? There will be tension acting away from each object, as you can see here in the string. Okay, and the reason why, of course, is if I'm pulling this object here with a force of 75 newtons, the string is like resisting, isn't it? It's like holding it back, because of course the string is attached to object B, so it's not going to have its own way. You're pulling it with that force, but the tension in the string is opposing it in that way. So you're always going to have the tension force going away from the shape, okay? From the object, away from it in those directions. So we can now apply Newton's second law. Okay, so first of all, if we focus at A, okay, well at A there's two directions to resolve in. So with A you can resolve in the direction of the table there, the motion we're going in. Okay, that way, so we've got the resultant force, 75, take away the tension in the string, okay, and that will equal to then 75 take away the tension equal to the mass, which is 3 kilograms times the acceleration. Okay, and then at B then, if we resolve in the vertical direction, we've got the tension is the bigger force, isn't it? Because it's pulling up B. T take away 5g, and that will equal to then the mass of B, which is 5 kilograms times A. So 1 and 2. Now we could also resolve vertically at A. So we could show then that R is equal to 3g, but they don't actually ask for that, but that would be the case there, yeah? So R would be 29.4 newtons when you times that by 9.8. But all we've got to do is work out A and T, and just like before, quite simply, we add simultaneous equations, we add them. So when I add these, I've got 75 minus T, add, Okay, so that there, add this equation, because we're adding, remember, 1 and 2. 75 minus t, add t minus 5g, and then we add these two as well, 3a plus 5a. So that's all I've done there. I'm adding this to this, and I'm adding this to this. Now, what happens then is the t's will always cancel, and you've got 75, take away 5g. Now, 5g, of course, is 5 times 9.8 equals to 8a. And then to work out a, you're going to work out that left-hand side. 75, take away 5 times 9.8, and we get 26 equals 8a. So then a will be 26 divided by 8, and we get 3.25 meters per second squared. We then sub that then into 2, maybe 2 would be easier. So t, take away 5g, 5 times 9.8 equals then to 5 times the acceleration. So t, take away, that becomes 49. 5 times 3.25 is 16.25. So then t then will equal to 16.25, add 49, so we get 65.25 newtons as our final answer.